we start recording. All right. So today, for our Java programming section, we are going to discuss doing math with Java values. So, what are some basic mathematical operators that you guys can do just like on a scientific calculator? What can you think of? What can you do with a very basic calculator?
Addition.
Addition.
Addition,
Subtraction.
Modulus.
Multiplication, division.
Multiplication and division, all correct. So we can do all of those same things in Java. We can do addition, subtraction, multiplication, and division. For each of these, you need two number values, whether they are int or double number values. And either value can either be a variable, or the value stored in a variable, or it can be a specific number. So in all three of these examples, I am creating an int value. So my number one is going to be 8 plus 2. I have two hard-coded numbers. And those are called literals. When I have, oh, I didn't mean to click. A literal is just when I have a hard-coded number, or any hard-coded value that the programmer types in. Num2 is going to equal num1 minus 6. So I'm doing one variable and one literal number. And then my num3 is num1 times num2. I can do math with multiple variables. When I do math with an int and a double, Java is going to default to having the most possible precision, so it will output a double-typed value. So here's our list of operators. We have our plus minus. Multiplication is done with the asterisk, which is on top of the 8. Division is done with the forward slash, not the backslash. And modulus is an operator that if you've taken a programming class before, you will probably recognize. If you've not taken a programming class, let's talk about modulus. So the modulus operator, represented by the percent sign, is used when we want to do division. And instead of finding the quotient of the division, we want to find the remainder. So if we remember back to doing long division, back when we first learned how to do dividing, so I want to find the result of 17 mod 5. So modulus, we can say mod to represent it. Mod and modulus are interchangeable terms. So we have our 17 underneath our division symbol. We have our 5. 5 does not go into 1 any number of times, so we jump to the next digit. 5 goes into 17 3 times. 3 times 5 is 15. We subtract 15 from 17, and we get 2. Since 5 cannot go into 2, we are finished with our division. So we get a quotient of 3 and a remainder of 2. So when my modulus of 17 mod 5 equals 2, it's anything that's left over when I'm done dividing. Does getting the modulus value make sense? Cool. All right, let's talk about a useful application of modulus. One of the most frequent places that this is applied is determining whether a value is even or odd. A value is even when it is a multiple of 2. So if there is no remainder when you divide by 2, you know that that value is divisible by 2. It must be even. A value is odd when it's not a multiple of 2. So the only available remainder when you divide by 2 is 1, because next number, that number will be divisible by 2. So when there is a remainder of 1, if you divide by 2, that number must be odd. So we can use our modulus to check, is any given number even or odd? All right, let's do a little bit of practice. What is 15 mod 6?
3.
3. Why is it 3?
Because when you do the division, it comes into 6 goes into 15 2 times, so that would be 12, and 15 minus 12 is 3.
Absolutely correct. Because the largest multiple of 6 that fits into 15 is 12, like Linus just said. So 6 times 2 is 12. 15 minus 12 is 3. So our remainder is 3. What about 10 mod 2? What is the remainder there? See Ryan going zeros? That is correct. There is no remainder when I divide 10 by 2, because 10 is an even multiple of that number. So the biggest multiple of 2 that fits into 10 is 10 exactly. So there's no remainder. Our answer is 0. Talk about what happens when you try to divide int values in Java. So when you try to do division with an integer value, with 2 integer values, an integer divided by an integer, you will not save any decimal places. The result of that division will be another integer value. So what happens is the decimals that would be produced get truncated, or they get chopped off. So if I tried to divide 5 by 2, I would expect to see 2.5, but I am going to truncate all those decimal places. I'm going to chop them off. I'm not rounding, I'm just chopping off decimals. So 5 divided by 2 is going to equal 2. That should say 10. 29 divided by 10 equals 2.9, except once again, we're going to chop off those decimal places. 29 divided by 10 equals 2. If we want to actually have decimal places resulted from our division, if we want to actually save the real value of it into a double, at least one of the 2 numbers being divided must be a double. And we can do that by just adding a decimal place at the end. So even if we're dividing whole numbers, if you just put a 0.0 at the end of one of these 2 numbers, then the final output will be an actual decimal. All right, do we remember PEMDAS? What does the P stand for in PEMDAS? Saw Ryan gesturing.
Parentheses.
Parentheses. What does the E stand for?
Exponents.
Exponents. What does the M stand for?
Multiplication.
Multiplication. What about D?
Division.
Division. Oh, I forgot. M also is going to include modulus because they start with the same letter. D is for division. A is for addition. And last,
Subtraction.
subtraction. So this is our order of operations. It's true in math, and it's going to be the exact same way in Java. So one last thing to remember is when you have multiple operations of the same level, of the same tier, so M and D are the same tier, and then A and S are also the same tier, you're going to read from left to right. So we're going to practice our order of operations. My mystery num, int mystery num equals this calculation. So I'm totally allowed to do this in Java. You can assign a calculation to a variable. It's just going to solve that calculation before it performs the assignment. So let's figure out what is going to be stored in our mystery num. What is the first operation that's going to happen here? All right, I saw parentheses 2 times 3, Kayla. Correct. So the inside parentheses, 2 times 3, that's going to happen first. 2 times 3 is 6. All right, what is next in our order of operations? Do we have any more parentheses that we care about? Do we have any exponents in here? Nope. All right, the next is multiplication and division. So next we're going to multiply 6 by 6. 6 times 6 is 36. All right, and then which is going to happen first? Do I do the addition or the subtraction first?
Addition.
Addition, because it is the leftmost operation here. So 4 plus 36 is 40. 40 minus 2 is 38. So when I print my mystery num, I see 38. And this 38 value is referred to as a literal. Anytime we create a specific value and assign it to a variable, that value is called a literal. So like I was saying way back at the very beginning, 8 is an integer literal, 2 is an integer literal. We talked about string literals a few classes ago. So any programmer created value that we type in ourselves is called a literal. Does that all make sense? All the math stuff? Sweet. All right, stop share.